Hello, viewers. Welcome to the Semiconductor Podcast. We are live streaming right now, and this is the third episode of the Semiconductor webinar. Today, we have with us a promising student, Selvalakshmi D, uh, and we will be presenting through the topic that you can see already in the screen. Let me give a small introduction of Selvalakshmi. Selvalakshmi D is an electronics engineering student from Banari Amman Institute of Technology, known for her passion for for pushing the boundaries of technology and bringing complex ideas of life through hands-on innovation. So over to you, Lakshmi.
Hello all, good evening. I am Selvalakshmi D from Trichy, Tamil Nadu. I am currently pursuing Electronics and Communication Engineering final year at Banariaman Institute of Technology, and I am deeply passionate about electronics. Today, I am really excited to share a project that's been both a personal and technical journey for me, building an SAP-1, simple as possible, 8-bit computer completely on breadboard using TTL logics and ICs. What makes this version more special is that I manually handle all control logics, giving me complete control, deeper insights into each cycle of executions. The idea to build this was initially proposed by Palani Vairavan, and it became a reality with the support and encouragement from Dr. Meenakshi Sundaram Manivanan and Hope 3 Foundation. Isn't it fascinating how computer perform complex tasks using just zeros and ones? Yes, that curiosity led us on an exciting journey to build our very own 8-bit digital computer on a breadboard. It was inspired by Bennett's legendary project, and it all begins at an electronics boot camp conducted by Dr. Meenakshi Sundaramanivanan during the Foundation's annual meet. There, we built the clock module, the heartbeat of our computer, and got hands-on experience with electronic components, circuit calculations, and practical debugging. I'm incredibly grateful to have been part of an eye-opening session and experience there. When I returned to college, I continued working on the 8-bit computer independently. It wasn't that easy to complete this project because this is not part of my college academics, but every challenges taught me something new about this project and helped me to bring patience and persistence within myself. This project helped me dive deep into digital logic and understand the real magic behind ones and zeros. Okay, now I look forward to walking you through how I designed, debugged, and programmed this machine and what I learned through every clock pulse and control line. And now we look at what is SAP-1 architecture. Next slide, please. Next slide.
Yes, I have changed the slide. So first
Next
slide
slide,
is
sir.
with you.
SAP-1
The next slide.
architecture.
Okay.
SAP-1 means simple as possible. This SAP-1 architecture was introduced by Malvino in digital computer electronics. He designed this basically for educational purpose, and we can perform tasks like load, add, subtract, out, and halt using this SAP-1 architecture. It demonstrates how CPU executes instructions step by step, and we are having multiple blocks in our SAP-1 architecture. They are clock, program counter, and our memory. And we are having three registers, that is register A, register B, and also our instruction register, and the adder to perform logical operations, and the controller that controls all the logics. The next slide, sir. Clock module. This is the heartbeat for the SAP-1 computer. It provides timing signals to control step-by-step executions of instructions. And this is the one first I built for this project. All operations in the SAP-1 architecture are synchronized using clock pulse. Actually, we'll tell our laptop is working more speed or less speed. It was decided by this clock only. We are having the potentiometer to adjust the clock speed of the computer. And we are having three modes in this clock. The first one is manual mode. In manual mode, clock is generated manually using a push button. Each button press produces one pulse, and it is useful for debugging step by step. The second mode is single step mode, one full instruction cycle per trigger. It helps to watch, fetch, decode, and execute as one complete unit. It is implemented with a switch and flip-flop logics, and we are also having the another mode to switch into automatic and a manual mode. And this all logics is built by the LM555 timer. It is the most important component for our clock module. And switches, resistor, and also we are having debouncing circuit because using push button we are also controlling manually, right? For that we should require that debouncing circuit. Next we look at the program counter. Next slide, sir. The program counter ensures sequential execution by automatically stepping through memory address. It allows the CPU to fetch instruction one by one in the correct order. It holds the address in the next instruction and let the CPU to know what it is performing at that time. It is built using 74LS161. It is a 4-bit counter, and it also stores and increments the memory address from 0 to 15 because we are having a 4-bit program counter. And the output goes to MAR via 74LS245. It is a bus transceiver. And for the complete project, we are using the 74LS series. And this transceiver helps us to output the program counter data to the bus. And next, we look up our memory address. Next slide, sir. The memory address and the RAM. I'll look at the RAM. It stores both instructions and data needed by the SAP-1 computer. It provides read access to the CPU via data bus. Instructions are manually entered using dip switches before execution. And it stores program and data in a 8-bit format. And we can store both instruction and data using the address from memory address and register. And we can transfer the data onto the data bus when it is enabled by the 245. And here we can look that we are having two LEDs, one is red and one other green. We can switch to the modes that we can input the data manually using the dip switches, and we can go with the PC data. And MAR, it holds the memory address from which the instruction or data is to be fetched. It, it acts as a pointer for the RAM to know which memory location is to access. The key functions of this memory address and RAM is it receives 4-bit address from program counter. It passes this address to the RAM for reading or writing. The MAR ensures correct memory location is accessed during each instruction cycle. And as a part, both the MAR plays a vital role in directing the CPU to the correct memory location using the stored address from PC or dip switch. We are multiplexing. We are having multiplexer circuits to multiplex our inputs. With the help of 157 and 173, it ensures smooth address transition and correct RAM access during every instruction cycle. Next, we look at about our registers and ALU. Next slide, sir. Yes, register is nothing but to store any things we required above. Likewise, To store our data, we require a register. In register, we are just storing the data with which we are going to perform logical operations. We are having instruction register, we are having instruction register and register A, register B. We are having three registers. That instruction register stores the instruction and it is a 4-bit register. We can have only 4-bit data in our instruction register and register A is act as an accumulator. In our instruction register, we split that 8-bit into 4 bits. The first 4-bit is for opcode and next 4-bit for the operand. The opcode only going to decide what task we are going to perform, like addition, subtraction, or load, or outputting the data. And the next four operands decides the address of the opcode. And the register A is act as an accumulator, and register B is also used to store the another operand. And in our ALU, we can perform addition and subtraction. To perform addition, we are using 283. It is a 8-bit cascading 4-bit adder. And for subtraction, we are using 86, that is XOR logic, to have a 2's complement. Because to perform subtraction with digital values, we used to follow the 2's complement. To calculate the 2's complement, we are using 86 for subtraction. And we look at the control logic units and output displays. Next slide, sir. At control unit, first we look up at the output. For output, we are having four 7-segment displays. We can output both positive and negative numbers. That is, we can show integer values with our 7-segment displays. And for output display, we are using 273. It is used to latch the data that is in the bus to the output, and the data is passed through lookup EEPROM to convert binary to 7-segment pattern. There is also multiplexing that makes digits appear simultaneously using fast switching. To be clear, control logics enable program flow by producing control signals in correct timing. The output model visually shows the result, making this computer human readable. Together, they allow smooth instruction execution and clear output presentation. For control logic, we can control in both modes. For manual control, to perform each instruction step by step, we can use the jumpers. We can control 15 control signals using these jumpers. If the instruction is up to 3 or 4 means we can do this manual method. But if the instruction is more than 5 or 6 cycles means it is not possible to control manually. So that we are going for microcode EEPROMs that is used to perform many instruction cycles more faster. We can also program the EEPROMs both manually and also using the controllers. For using manually, we use dip switches and programming circuits to program the EEPROMs. For using microcontrollers like Arduino and Arduino IDE, we can program the EEPROMs to perform the biggest task, which includes multiple instructions. Next, we go to instruction set and programming. Next slide, sir. Okay. Programming an 8-bit computer is included with fetch decode cycles. It means manually loading binary instructions into the RAM using 4-bit opcodes and 4-bit operands to perform operations like load, add, and output. It is a great way to understand what happens behind the scenes in modern computers. This control logics helps us to do step by step using manual logic sequencing. This gave me hands-on experience with how each instruction passes through the classic fetch, decode, execute cycle. The cycle repeats for each instruction. We use T states from T0 to T5 for timing and precision control. In SAP-1, This is managed via 15 control signals, as I said before, to control the micro operations. During fetch, the program counter inputs to MAR and the MAR to instruction register. During decode, the opcode and operand split takes place. With that only, we'll get to know what operation going to be performed. And during execution, micro operations triggered manually using toggle switches. And this is how the programming takes place in a 8-bit computer. We can see what are the possible program we can perform with SAP-1, that are we can add or subtract two numbers. We can load and display constants, and also it is possible to output ASCII codes. It is a basic character demo. And the limitation is we can't perform jump or branch, and no loops, no conditional execution also takes place because it is a simple architecture. With that, we are having limitation to perform only basic tasks. Next slide, sir. These are the control signals with which our entire computer works. And similar to this, only our laptops, PCs also perform operations using control signals. Halt, halt means it halts the system. If the halt is high, the entire system get halted. MI is a load address into memory address, that is from MAR, and RI and RO are RAM input and output operation, IO and IR instruction register input and output operation. This everything is inputted to the bus. We are having one single common bus. With into that bus, we can input or output data. And A and AO is register A's input and output, and register B input. OI is the load data into output register. For output register, we are loading our data. SU is the sum output subtraction. If SU is high means only we can perform subtraction operation. Otherwise, default it will be adding two operations. And EO is the enable ALU output onto the bus. With this only we can see the output values of addition and subtraction. And CE is CO is program counter enable and program counter output. Each program counter enable press will increment the program counter. And the jump is to load PC with operands. Next slide, sir. Yes, let's talk about the fun part, the bugs, the burns, and the breakdown moments. Burnt ICs. The first time my ALU stopped working, I thought it was a loose jumper. Turns out I had reversed the VCC and ground. As a result, I got a toasted IC. And the lesson I got is double checking your power lines is always an important one. And wiring, imagine tracing one missing connection on a group of 150 plus wires. It was like diffusing a bomb without no timer. While finding the error in wiring, it is a very difficult task. Should have patience. That taught me patience become my best tool. And clock bounces. I underestimated the need for debounces until I saw my register behaving erratically. After diagnosing timing mismatches, a simple RC debouncing circuit brought everything back to the rhythm. A simple circuit we may not consider this as a big impact, but yes, a simple circuit is an impact. And instruction missteps. Initially, when I doesn't know about assembly language programming, I initially misunderstood the micro operation for add. My control signals were firing out of order, and instead of 28 plus 14 as 42, I got 255. Then only I relearned about that opcode and corrected my mistake and got the correct output. And how I overcome all this was started modular debugging. Tested one block at a time. If I'm getting an error, I'll take the chip separately and I'll build a separate circuit to test the IC alone. Likewise, I tested each and every block if I got any errors in that and used LED as an indicator to trace control signals so that we can let to know which IC is performing and which pin is not working like that. It is a very important and helpful method to use LED as an indicator and referred constantly to IC datasheets. Sometimes we have to go through IC datasheets. In datasheets itself, they mention many things. For using normal gates, we can perform directly. But from some ICs, we have to use resistors for pull up the pins. That is more important. While taking the IC and perform circuits, we doesn't know that whether this IC requires that pull up or not. While reading the data sheet only, we'll come to know that yes, we have to put pull up resistor to make the IC to perform in a very good manner. So always read data sheets constantly to know how to make use of that component. And I followed Benitez videos that and recreated timing tables to correct my steps. His videos helped me a lot. That was the only tutorial that I had, a reference that I had to complete my project. That helped me a lot. And each challenge wasn't just a roadblock, it becomes a lesson in patience, precision, and the beauty of making mistakes. Being perfect is not important. If I didn't get any mistake or I didn't did any mistake means I learned nothing. This project outcome is completely based on the mistakes what at all I have done. So making mistakes is a very beautiful thing for our learning and growing. And next slide, sir. Learning outcome. This project wasn't just a technical build, it was a personal transformation. Here is what I gained. I gained both technical and also soft skills. While looking at technical, I mastered the step-by-step execution of instruction using the fetch, decode, execute cycle. It developed a deep understanding of registers, buses, memory control, and manual logic sequencing. And I learned how to read and apply IC data sheet and design clock control and implement an ALU using discrete logics, etc. And I gained real world experience in debugging digital circuits and interpreting behavior of from LED indicators that made me to understand all digital electronics, how it works with zeros and ones can make everything possible. And as a soft skill, I gained more patience. That is the biggest thing I got from this project. Every short circuit, every unexpected output taught me to pause and rethink. Attention to detail, a single misplaced jumper wire can alter the entire flow. I learned to be precise and double check always. After getting 10 to 12 mistakes, I started rechecking the connections. Previously, I don't used to recheck. If I see the schematic and connect once, means that's it. Now, even a simple circuit, I automatically going to recheck the circuits and problem solving under pressure. With limited time and tools, I became creative and resilient in debugging. Sometimes, if I have sort of multimeter, at that time I took LED for indication purpose and to check whether there is a power supply or not. Likewise, each and every mistakes and lack of resources will make us to create something and think out of the box. That will be the learning for our entire work wherever we are. And also never think that we require all the resources to do the project comfortably. Lack of resources and out of comfortable zone will make us use of that project and learn things throughout. And independent learning followed reference, tested ideas, and built confidence in hardware design through experimentation. This project was completed by independently me alone while So many times I'll get frustrated during this because sometimes we doesn't know what can be an error and we don't have any references or many things like that about our problem. That was how to be corrected by my own. Not always it is get smooth road. Sometimes get more frustrated, but how to overcome that to get such results like this. From blinking LEDs to recoding instructions, I didn't just build a computer, I built a new way of thinking. Right. And finally, I want to thank Palani Vairavan for initiating this project idea, Dr. Meenakshi Sundaramanivanan for guidance during the boot camp, and without his mentorship, I can't complete the project, and the Hope 3 Foundation who led the platform and encouragement for me for this project, and Beniter, whose tutorial inspired the entire build, and also my family and friends who supported and motivated me throughout. And special thanks to Tech Simplify the TV for this opportunity to present. Thank you, Mridul sir. Thank you. And thank you all for your time and attention. This project was a challenging yet rewarding journey. I hope it inspired you to look deeper into how computers really work beneath the surface. Feel free to connect with me if you have to discuss further or build something similar. And now I'm open to your questions. You can ask. Thank you.
So, viewers, we have Lakshmi today presenting amazing thing. It caught my attention in the LinkedIn from a post which was then probably reposted by someone else, and then it come to my feed. Uh, Through the semiconductor webinar, we are trying to spread the peer learning. That means whatever happening in a college, a particular student like Lakshmi today, she has built an amazing thing. After working so many years in the industry, when I saw this, it caught my attention because this work has a full potential, right? If this kind of endeavor is taken by a student, the brightness of the student in the microelectronics and the VLSI industry is about to open. And we saw this, and we would like to spread the message through the semiconductor webinar that we highlight students who are doing an excellent thing, presenting their knowledge, presenting their project, and that's how we are showcasing. In the industry, the learning is called continuous learning, and it has multiple segments. One is read from the pre-recorded videos like we do. One has come from the seminars, one that comes from the papers, theses, all of these things. Sometimes there are basic hands-on training institute, they provide a knowledge. And the most important part, peer learning. Peer learning is a very important thing because when you learn from your peer, like today Lakshmi shared her work in through a PowerPoint presentation, right? Thus, seeing this work, I strongly believe that many of the students will come forward and showcase their talent. And I would like to share my thoughts on this ground that due to the colonial hangover, right? Whatever we do, we are not enough confident about that. And exceptions are highlighted only. Now, if you are doing an exceptional work, the semiconductor webinar is for you. So that's why we have started this webinar series, the semiconductor webinar. People from industry also can share their knowledge, their technical knowledge, not their business pitch, through this webinar. The peer learning is something that you cannot have from a book. Today, viewers who are watching it live or maybe watching it later on, right? So, viewers can actually have a feel that today we have covered a tremendous work. Tremendous work means the work at the scale. If you can translate this work in terms of designing a particular circuit in the IC itself from scratch. Obviously, we have different models that we can start with and then go with the flow. However, this is the work that can be started from the scratch, and this is this should be a practice for all of our students. Especially, I am focusing on the Indian subcontinent. If the students from other countries can contribute to this particular platform, that is open, we are open to all, and we should make and exemplify the exceptional works that are done by students so that their voices, their work reach the right ears who can open the doors for their bright future opportunities. This is our mission in Tech Simplified TV that we perform here through the semiconductor webinar. And here again, I will say that the peer learning is the best, because when you see someone probably at your level, say Lakshmi is a student, and someone else who is a student is watching this webinar, sees it, and it inspire him or her to do a work and do a challenging work and not stopping with multiple fails and finally achieving the result, it would be great. I was in contact with Lakshmi, I think, for 2 to 3 months for this. And Lakshmi is very listening to me in very serious way and even not smiling. And before even coming to this session, so there was a lot of questions how these things will be presented, who are the audience. Now in our channel we have a global audience. That means our channel is viewed across the 90 countries of the world. Obviously not simultaneously, not every moment or second, but in bits and pieces our channel is accessed through 90 countries. So I want to reach out to the students who are doing a great project, and this is free for you. You don't have to pay any single penny, and here we are to highlight your work. And this is the purpose of the semiconductor webinar. So thank you, Lakshmi, for presenting your work to the students. This will encourage a positive vibe among the engineering students to come forward, to come out of the inertia of what to do and what not to do, and what is good, what is bad. You give your level best, try it, achieve, perform. It's okay to fail. You repeat. If you have some other failure, go ahead, correct it, and finally achieve the thing. And once again, I would like to say that here in this platform that no one is perfect. If you are trying to perfect, being a perfect, it's from the colonial hangover we had years after years from the different colonial um, regimes that stayed on our country. So I would like to uh, say that leave out that inertia, be confident, do your work. And here in the semiconductor webinar, we are there to highlight you. We are highlighting students to inspire more students to become courageous and take challenging work. Industry needs this kind of courageous peoples to build the future. Today, what you see, the smartphone, the laptop, the tab, All those things came out of the effort of courageous people who started thinking in a different direction. So if you have something in you that you want to prove it, go ahead for a work. Anything I am saying about, whether it is hardware, or you have to do something in the VLSI design, chip design, or you are doing an Arduino project, and you are making something that shows your potential to do it, and as well as inspire others. This is very helpful because in today's social media environment, one thing is very, very bad thing is spreading, it is jealousness. As an individual, when you are there in social media, you watch others success, someone get inspired, someone get jealous. So both positivity and negativity is here. We are here the semiconductor webinar to spread the positivity and cut down the negativity, because we are open, we are openly approaching you. If you have something, we have our email ID, business@techsimplifiedtv.in. You can reach out to there. You can connect me with LinkedIn, me, Munmun, anyone you can connect with in the LinkedIn, and we are there to present you. And honestly, in the semiconductor webinar, we are not charging students. You have your mentors in the physical world, in your university, in your college. Do, and it is the platform to pay the respect to them. And we will be continuing this journey with more and more students and highlighting their real time work, because generally no usual media, our general media, they are busy in political and geopolitical and Bollywood and other movie industries. So they are pretty much shifted away from the talent pool of this country, who are the future, who will be looking forward. They will build the world in the next generation. So this is have its very, very huge impact on the community, and that's why we are using a social media platform, YouTube, to beam the semiconductor webinar. The semiconductor webinar is a different kind of webinar, and it stays recorded. Even for me, if I try to attend some webinar, I miss because of my life's other priorities. I cannot see it. But Tech Simplified TV has arranged the semiconductor webinar in a way that it will stay recorded in the platform. At some later point, you can watch it. And I would like to ask Lakshmi that in case you have some message to the students who are your peers, uh, so that they can take the challenges head on. Anything from your side?
So actually, if we are having a passion and also we want to do something means we are not having the correct environment all the time. Even while doing this project, I don't get enough time to spend time for this because I was engaged with college academics and also college assignments, projects, everything. At that time, we'll have two options. One is continue with whatever the work we are engaged at that time, and also we can't get the time in a easy manner. We have to make time. We have to sacrifice something to spend time for that because we are the one who are going to prioritize, and nothing is that hard to think of it is not possible, we are not able to do it. If we think means everything is possible. I also thought that I can't complete this project before completing my college like that, but I made time. I spent my holidays and I completed some of my college works faster to make time for this project. So likewise, if we think and we decided to complete it means it is not that hard to spend time or Even lack of resources will not be a problem if we decided to complete. So if you want means go for it. Don't think I didn't have confidence that I'll complete this project because I was doing it individually and even I don't have any help while doing this project. So working completely individually is very hard. But at that time, we'll get down. During that period, we have to decide that we'll try it and it not come by overnight. We have to work for it. One small mistake that I have done through my project, it is a very silly mistake. But I was worked for 2 days completely to correct that mistake. But it was a very simple, silly mistake. So it is not, we are thinking that everything is very hard and bigger. While that mistake, I thought the project is stopped there itself. If I'm not worked for 2 days for that work means definitely the project was stopped there itself. I don't get this result. So if you are getting very low and you decide that you can't continue, just give a try. Give some more minutes, some more time, even one more day, and try to find it. Because that reaching threshold will make you to give a good result and complete what you think of. So push your limits as much as possible so that nothing is very hard. You can do it.
Yes, that was the message from Lakshmi to all the students who are her peers right now. And the students who are watching this must also get encouraged. I'm personally encouraging you. Okay, Tech Simplified TV is a platform which gives you to present things. So if you have something to present, you can come and present. We'll have a dry run and then we'll present in the actual event. Now, the part is that why we keep in our own cocoon and we do not want to come forward because we have a lot of conventional beliefs that is this good, is this bad, am I able to do it, so these kind of things has come from generation after generation from the colonial hangover of Indian landscape. So I appeal to the students, get out of the colonial hangover and try your level best, be confident, do the projects by your own or with some guide you have in your vicinity, and we are there to present you here in the semiconductor webinar. And also my suggestion to all the students to watch the semiconductor podcast because we are bringing industry leaders so that the unknown path that you do not know from your textbook or from your school or college, the leaders are there, they share their journey through the semiconductor podcast. So that will be very very helpful for you guys to decide how you move in the unknown territory in the future, because future is always unknown, but at least one generation can guide the next generation. So the semiconductor podcast is designed for that, to bring the industry leaders here and speak about their journey. And here in the semiconductor webinar we are bringing the upcoming generations who will be the future, who will make this world a nice place for the future with positive vibe, positive work, and spreading positivity. So, all we have the semiconductor webinar and the semiconductor podcast to spread out the positivity and cut down the negativity that is coming as a byproduct of the social media today, because mostly it is passive. Here it is active. In the semiconductor webinar, you can participate, you can put your questions in the comment section, or in the semiconductor podcast, you can put down your question in the comment section. So it's very active. You have to be there to ask the question if you have something in your mind, or in case you are the presenter, you want to present, you are always welcome. You can access us through our LinkedIn handles or our email ID, that is business@techsimplifiedtv.in, which is displayed in the About Us page of our YouTube channel. So, with that note, we will say bye to our viewers And we would like to thank again Selvalakshmi today for presenting her work to encourage the peer learning that a student must learn from other student through their achievement and get the confidence and the boost. Thank you very much for being here, Selvalakshmi. In
Thank you,
future,
sir.
if you do something more encouraging, we are there to present you again. And have a nice evening. And we will say bye to our viewers. Bye. And one more thing, uh, I would like to pay my respect to Dr. Minakshi for guiding Lakshmi and the Hope Tree Foundation. They helped her a lot of way, because this platform is to encourage people to spread the positivity, and that's what we do through both the Semiconductor podcast and the Semiconductor webinar. Thank you, viewers, and bye for today. We will be signing off today. So we will meet in another exciting episode of the Semiconductor podcast or Semiconductor webinar in upcoming weeks. So stay tuned, stay focused. Bye.